Alright, the mean value theorem. Okay, I'm going to ask a volunteer to read this theorem for us. Who want to read? Brady?
Let f be a function that satisfies the following three hypotheses. F is continuous on the closed interval AB. F is differentiable on the open interval AB. Then there is a number C in AB such that f prime of C equals fb minus fa over b minus a, or equivalently fb minus fa equals f prime C times b minus a.
Okay, very good. Well, first, it's not a three hypothesis, okay, so we consider only two, okay. So this is the typo, okay, this is a typo. I would say if F satisfies these two hypotheses, okay, hypothesis. What are the two hypotheses? It's the same thing as the first two hypotheses from the Euler theorem, okay. If F is continuous on the closed interval, F is differentiable on the open interval A to B, okay, there's no third hypothesis, okay. The third hypothesis in the Euler theorem tells us that at the two endpoints, the F value equals each other. However, in the mean value theorem, we don't have this hypothesis. That means, you see, let's look at the graph, okay, here. This is A, this is B. F of A does not equal each other, okay. So this is f of x when f of x varies between A to B. Okay, see, f of A does not equal f of B, okay, so we do have the third hypothesis from the Euler theorem, okay. Okay, then, okay, if a function satisfies these two hypotheses, okay, then there must be, okay, there exists a number C between A and B, okay, such that the derivative of f at C, which is the slope of the tangent line, so this is a C, okay, which is the slope of the tangent line to the curve at when x equals A, this is f prime of C, okay, it must equals what? F of B minus f of A equals B minus A. What is this? It is the slope of what? This line segment between A and B. Do you see? Say, if I'm, connecting this point and that point, we have a line segment. Do you see the line segment, right? What is the slope of this line segment? What is the definition for the slope of the line segment? A equals what? For this endpoint, what is a y value? What is what is a y coordinate for this point? Equals what? Divided by what? B minus A. So change in y divided by change in x. Okay, change in y divided by change in x give us the slope of the line segment. We learned this before, right? In college algebra, right? Okay, so see, the slope of this line segment equals the slope of what? This tangent line. Okay, same thing here. Okay, so this is another case. Okay, this is f of B is greater than f of A. Okay, so see, there are two C's such that there are two tangent lines. Okay, f of C1, f prime of C1, this f prime of C2. The slope of these two tangent lines equals what? The slope of the line segment. Okay, and then what is the slope of this line segment? Same thing, f of B minus f of A divided by B minus A. You guys see that? Okay. Why just now I said Euler theorem is a special case of the mean value theorem? It's because for Euler theorem, f of A equals f of B, right? So let's plug in the mean value theorem. If f of B equals f of A, the subtraction is 0. So 0 divided by B minus A. B minus A cannot be 0, right? Because B is always greater than A, right? So 0 divided by a non-zero number gives us what? 0. So that means if f of A equals f of B, f prime of C must be what? 0. So that's why Euler theorem is what? Special case for mean value theorem. Mean value theorem is more general. It does not need us to have what? f of A equals f of B. Guys, do you see that? Okay, so this is the mean values theorem, okay? Well, a lot of times we use this, or we can use this as well, okay? Sorry. Okay, this equation and this equation, they are the same thing. Do you see why they are the same? This and this is the same. Because from this equation, if we multiply by what? B minus A from both sides, what do we get? We have a f prime of C times by B minus A, right? And equals what? F of B minus F of A. So either way, okay? So I, most of the time, use this, okay? But you know, this one and that one, they are the same, okay? They are the same thing, okay? Alright, so I need you guys to memorize this conclusion as well, okay? F prime of C equals F of B minus F of A over B minus A. Alright? Alright, so now let's use mean values theorem to do practice question, okay? Alright, so example. Verify that the function satisfy the not 3, right? Satisfies the hypothesis of the mean value theorem, which is continuous differentiable, right? Just 2, okay? Then find all of the C such that A satisfies the conclusion of the mean value theorem, okay? So we have the question A and the question B. Question A is a polynomial. I want you to try this one by yourself, okay? So let's try question B together, okay? Verify this function satisfy the mean value theorem. Y equals nx. What is the graph for a log function? Remember? Yeah, this is log of x to base e, right? Base e is greater than 1, so we should have an increasing, briefly, okay, my picture is briefly, okay, increasing log function, okay, so this is y equals ln x, okay, this is when x equals 1, okay, log function always pass through the key point 1, 0, right? 1, okay, so the domain for this function is from 1 to 4. So on this closed interval, do you think this function is continuous from here to here? This part, it is continuous? Yes or no? Yes. Okay. So f of x is continuous on the closed interval 1 to 4. Okay. Is this function y equals Lx differentiable? Can we differentiate Lx? My x is between 1 to 4 and then open interval? Yes. F of x is differentiable. You have to write this down in your exam, okay? Because question is asking you to verify this hypothesis, right? So verify that, okay? F of x is differentiable on the open interval 1 to 4, okay? So that's it. So satisfy, right? The function f satisfies both of the hypotheses. So that means there exists this number c, which is between 1 and 4, such that what? The derivative of the function, what is the derivative of f? What is it? 1 over x, okay? So such that f prime of c equals 1 over c, right? Equals f of b, ln what? 4 minus f of a, f of 1, right? ln 1, divide by what? b minus a. What is b? 4? 3. Minus 1. Yes, you're right. Okay, so we will solve for c from this equation, right? Solve for it. Okay, so let's see. 1 over c equals, what is ln 1? 0. So on the top is ln 4. On the bottom it is what? 3, right? So if 1 over c equals ln 4 over 3, how about c? I would say c equals 3 over ln 4. Reciprocal, right? 1 over c equals this, c equals 3 over ln 4, right? Alright, so can you please use your calculator and then get me decimal number 3 divided by ln 4? Approximately equals to, and see whether this C is between 1 and 4 or not. Let's check. 3 over ln 4, what do you get? 2.16. Round it, okay? Is 2.16 indeed between 1 and 4? Yes or no? Yes. Okay. So that means the 2.16 say 1, 2, 3, and 4. Okay, it's 2.16 is somewhere. Okay, over here. So if we draw a tangent line to the curve when x equals 2.16, okay, the slope of this tangent line must equal what? The slope of this line segment. You see that? Yeah, it is, right? Okay, so this is this type of question. Okay, so verify and then find the C value. Okay, this type. I'll let you try this one. Okay, in group. Okay. All right. So we do have the other type of the questions involving the mean value theorem. Okay, let's try both of them together. Okay. So this example, I'm going to ask a volunteer to read this example for us. Who want to read? Who haven't read yet? Mark?
Suppose that f of 0 equals negative 3, and that f prime of x is less than or equal to 5 for all values of x. How large can f of 2 possibly be?
Yes. Okay, good. Thanks. F of 0 equals negative 3. We don't know what f looks like. We don't know what kind of function it is. Alright, and the derivative of x is less than or equals 5 for all of the x. How large can f of 2 possible be? Mean value theorem. Remember the mean value theorem? F prime of C, okay, well this one, okay, we don't have C, say use X, equals what? That's F of B minus F of 0 divided by B minus 0. From the given information, guys, can you tell what is a B value, what is A value? What is A value? 0. What is B value? 2. Okay, so by the mean value theorem, the derivative of F equals f of b minus f of a divided by b minus a. And do we know the f2 value? Do we know it? We don't know. Do we know the f of 0? Yes, it equals negative 3. So minus negative 3 divided by 2 minus 0 gives us what? 2. It says the derivative of f cannot be greater than or equals 5. So it's going to be always less than or equals 5. Now from this inequality, can you find the f of 2 value? So f of 2 plus 3 over 2 less than or equals 5. How to isolate f of 2? Multiply by 2 from both sides. Less than or equals what? 10? How do you isolate f of 2? Yeah, minus 3 from both sides. So f of 2 will be less than or equals what? 7. Okay, so actually it tells us if f of 0 equals negative 3, it is here. And f of 2 is, we don't know, it is, I don't know, we don't know it is where, but we know that between this point and the other point, we don't know. We're looking for this, okay? We're looking for this, okay? What? This is the slope of the line segment, right? It consistent with what? The slope of the f of x when x between 0 to 2, okay? So, because f of x, the slope of the line segment cannot be greater than or equals 5. It's less than or equals 5. So that means when x equals 2, the maximum value, when we solve for it, it should be what? Less than or equals what? 7. We don't know what is f of x. We don't know we have no idea what this f looks like, between the, when x equals 0 to 2, we don't know. However, we know the slope of the tangent line, okay, must be what? Consistent with what? Consistent with the what? The slope of the line segments. So we can check, the slope of the line segment equals f of 2 minus negative 3 divided by 2 minus 0. Because the slope cannot be greater than 5, or it should be less than or equals 5, we build an inequality. Then we can solve for the maximum value for f of 2 is 7. Do you guys see that? Okay. The next example, okay, I'm going to ask a volunteer read it, and then I'm going to ask, let you guys try it, and then we do it together, okay? Whose turn? Dave? Read, can you please read the question, please?
Does there exist a function f such that f of 0 is equal to negative 1, f of 2 is equal to 4, and f prime of x is less than or equal to 2 for all numbers of x?
Okay, very good, thanks. Try it, please. F of 0, f of 2, they are given. Okay, the y values are given. The x values, the a and b values are also given, you can tell. So we may find the derivative, we may find the slope of the line segment. And then you're going to check to see whether there exists such a function f will satisfy all of these conditions. No? Why not? Simon, can you tell us?
I just plugged it in.
You plug it in, right? So the f prime of x equals what?
It's 4 plus 1
4 minus negative 1, right? Divided by what?
divided by 2.
Right? So it is 5 divided by 2, right?
Yes.
Because of the slope of the line segment is 5 over 2, which is greater than 2, right?
Yes.
So can we find a certain f, whatever the f it is between, when x equals 0 and 2, can the slope equals less than or equals 2 for all x? Yes or no?
That's impossible.
No. Okay. So no. Does it exist? No. You're very good. Okay, yeah, very well. Alright, so